Hey folks, welcome out here to TN Learn Mathline Summer School Style. We are here in the summer, and you are too. I'm Ernie Roberts. I'm your host for this afternoon's session of TN Learn Mathline. Thank you for tuning in, and we've been having some fun getting back to really the basics, and we're going to continue to do that this week and throughout the summer. We're going to be giving you remediation times, chances to really learn pick up some skills, those kind of things that will help you get ahead for next year in your school year. Fall's not too far away, but we're going to enjoy summer while we can. Now, this is not a call-in show, but you can still send us problems that you want to see, problems that you want us to deal with, questions you may have. Do it to our email or also to our Facebook. We will love to pick you up there, all right? But for today, it's all about, well, let's see what it is all about. Guys, what do we got for our slate today? We like to multiply. Well, we've been multiplying quite a long time. We're about to run out of those, but we want to make that important practice time in TN Learn Summer School Mathline. What are we here for? To help you and get you better and better at those times tables and such. So that's where we're going today. So let's see what our first problem situation is all about. Applications. You know, let's just not just multiply numbers all the time over and over and over again, but let's have some context to them. Let's put them somewhere where they make sense. And the area of a rectangle, that good old, you know, some of you want to call it a square, but this one's not quite a square because the width is a little bit more than the length. Did you notice the way that was said here? It says find the area of a rectangle if its length and width are 7 feet and 8 feet respectively. Now the word respectively, I have sometimes go like, what does that mean? And it is kind of a fancy long word, isn't it? It basically says that the length goes with the 7, the width goes with the 8. All right, just in the order that the two words length and width came in goes with the same thing with the 7 feet and 8 feet. We are in feet here to find the area. It's all about multiplication. And once we multiply them out, we're going to have square feet. All right, which people say, that's such an interesting concept. That's a strange looking thing. It means we're going to get little squares that are foot by foot. Okay, how many of those can we put inside that rectangle? But let's take a look at the problem first of all. By getting ready, we have 7 and 8, and I said something to the fact that we have to multiply. So a quick formula, I'm going to write it down here. We'll take the length times the width, and that's what's important, is know that we have to multiply. And then, once we've got that, is to be able to multiply. In other words, know our times tables on these. We're going to keep a few more runs on the times tables today. And let's see what's happening here. 7 feet for the length. All right, so I'm going to put 7 feet here. And I'm going to put another way to write multiplication. We can put in parentheses times 8 feet. All right. So in other words, we're going to say, what is 7 times 8? Now, I hope you all know it's not 54. That's right. That's 6 times 9. So many times, because they're so close to each other, we get a little confused on that. And then, oh my goodness, bring 5 times 11 in there to get 55. It really gets confusing. But what number is 7 times 8 going to give us? It's going to give us 56. All right. So we got 56. And I have feet times feet. And notice I said something about that. It gives us what we call feet squared. All right. It's a nice way to start learning that, because when you start multiplying variables in algebra and pre-algebra, you're going to say x times x, which gives you x squared. A times a is a squared. So feet times feet is feet squared. How about that? Works great, doesn't it? Absolutely works great. By the way, that simply means, you say, what does that mean? It means we have 54 square feet, SQ for square, and feet for FT. We usually use that. But that's the idea. So a square foot is a foot by 1 foot. Nice little square. We put 56 of those inside this rectangle. We'll fill it up completely, and that's our area, 56 square feet. Now you could also said 8 times 7, but just remember, we did say the width was 8, and we said the length was 7 in this case, but commutative property would still give us the same amount of area. So it's a moot point. It just happened to be we follow the formula there, all right? But that's our starter. That's our starter. We're all about multiplication today. A few more examples. We're going to do a lot of area. We're going to do a lot of area today, and also maybe throw a perimeter or two in there. You never know. You never know. And a little money. Speaking of a little bit of money, let's take a look at our next value here. It says, how many quarters are in $12? Now, off the cuff here, quarters. We got to remember what a quarter is about. You say, well, they're 25 cents, Ernie. But even more importantly, what we got to remember is how many are there in every dollar. In other words, if I give you a dollar bill, how many quarters do you give me back in change without shortchanging me now? Some of you get sneaky. Some of you might really feel nice to me and give me an extra quarter. That would be nice also. But for a true exchange, $1, that's $1 equals 4 quarters. I guess that's why they call them quarters, because you think of 4, right? How about that? All right. So we got 4 quarters equaling to $1. Now, the story is we have 12 of those dollars. So what are we going to do? You get to $12 to find out how many quarters we've got. Well, it sounds to me like we're going to have to multiply 4 and 12. It's all about multiplication, isn't it? We like to multiply. We love to multiply. We're going to do it. So let's take 4 times our 12. Y'all got that one down, I hope. Got the 4 times 12, the 12's tables? Woo! Yes, you should know the 4 times tables. And on this one, you don't have to really think. You just do 2 times 4, 1 times 4. You got 48 quarters. How about that? 48 quarters. And that will give you $12. Because once again, remember, each of those, 4 of those at a time, give you $1 back. All right? So there it is. Multiplication, rock and roll. We're looking good. Gives us 12. Now, where does that go in money? Let's not leave this yet. Let's suppose I ask how many dimes would be in $12. All right, let's just say. You say, well, Ernie, it's not part of the question. Well, we're saying a what if. We're going to say what if. So how many dimes? So let's think about it. In $1, there are 10 dimes. So let's go back to that relationship. $1 equals 10 dimes. All right. We want to know about $12. So we're going to take 10 times 12. Again, nice to know those times tables. And this one's really easy because all you got to do is put 12 and add a 0, right? So it's going to give us 120 dimes. And life is good. Life is good, all right? And that's our story there on this kind of thing, conversion. But guess what? Since we were having $12 and $12, we got to know how to convert. We got to know how to multiply, all right? And that gives us, again, 120 dimes gets us back to $12. Easy, easy money. Easy money. I wish it were that easy, but it is. It's good stuff. It's good stuff. So let's do another money problem here. Let's take this one and see where it's going to go. This one sounds a little more advanced, all right? And what we've got going on here is movie tickets cost $11 for adults. You got that? Over 12 years of age. Now, 12 years of age, number 12 is not going to come into play in here, all right? What we need to get focused on is that we have a $12 cost here, and we have popcorn costing about $8. You know, popcorn gets more and more expensive every year, it seems like. If you get a big tub or a big box, it really does begin to cost you. It doesn't cost that much to make it. Folks, that's how they make money at movies, is on concessions. These tickets basically go back to the movie company. They aren't gouging you. They're just giving the money back to the movie people who produce. Anyway, how much money will we spend on a family of 6 if they buy both items? All right, so in other words, we got everyone buying $11 tickets and everyone's buying $8 popcorn. We want to know the total cost. It's kind of scary, all right? So anyway, we've got 6. We're going to be worrying about family of 6. That's important right there. It's a lot, and they may be just a bundle of friends, maybe multi-generational family of 6. But here we go, 6 people coming in together, all right? So we're going to say 6 times $11. Nobody got a senior discount, doggone, or a child discount. We're going to all go at $11 there, all right? And popcorn, they don't care how old you are. You pretty much pay the same amount for popcorn, all right? So we're going to have 6 times that $8 popcorn box. That's our setup right there. Now, this is a 2-part situation. This is where if you go bumbling along here and you don't think about order of operations, you're going to spend a lot more money. You're going to have a mess, actually, if you go and try to work this across. What you need to do is what I underlined here. That's ticket cost, and that, folks, is your popcorn cost, all right? So in other words, we're going to multiply 6 times 11. We're going to multiply 6 times 8. That goes first. Now, that's order of operations. We always multiply and divide before we add and subtract. All right, so let's take care of that. And by the way, this is really where a problem like this makes sense. When people try to remember those order of operation rules, think about it this way. You do not want to come along and say 6 times 11 and then add 6 to that result and then come back and multiply it by 8. You're going to have a very, very expensive outing, all right? And not a very fair one, okay? Because you've just been cheated out of a lot of money. So let's do it this way. Let's do it my way. Let's put a 66 right here because that is what we know 6 times 11 is going to give us. On down the line here, we get 6 times 8, which is going to give us 48. It's still dollars because that's what 6 times 8 is. Again, you know your multiplication tables. Life will be good, all right? Now, adding these together, off to the side here, I think we can do that mentally. You know, I think we can, but let's do it anyway, off to the side. Some of you are going, please put it off to the side. All right, we're going to add them together, and it looks like I've got 14 going this way, send a 1 over in the tens column, and I've got 114. That's still a lot of money. That's a lot of money there. Now, someone's going to think, Ernie, and I hope you are. You know, I always say that. Someone's going to say, could we have added 11 and 8, got 19, and just multiplied one time by 6? We could. I don't know the 19 times tables, but I do know this. 19 is close to 6. Well, it's not close to 6. 19 is close to 20. Let's do that. Let's see what 20 times 6 would give us. Now, 20 times 6 is easy to figure out. 19 is not very close to 6 in case some of you were wondering, what is he talking about? Got a little sidetracked. That gives us $120. Now, look, I'm supposed to be at 114. So if I subtract 6 from here, guess what? Yes, we are. We're at $114. So yes, you could work it out either this way, you could work out this way. Personally, I think the additions and the numbers are easier here. But if you got a good thought about that 20 times 6, actually that works pretty quick too. Do 20 minus 1. How about it? Get a little change back from your $120. Woo! $6 back. All right. Anyway, we digress a little bit. There's your money moment. There's your money moment. Let's go back and do a rectangle again. All right, let's do a rectangle one more time here. Actually, we're going to probably do a lot more times than one. You got an area of a rectangle if its length is 8 feet and you have a width of 9 feet. Wow, that is a pretty good rectangle. Now again, think about it. There's the length as we tend to look at it. Width is going to be a little longer this time than the length, and back together. All right, there's your rectangle. The formula, as we used last time, is area equals length times our width. Very straightforward, very easy to do. And we're in feet again, all right? So not much happening here except we're going to just review. We're going to review what we had just a minute ago on the show. So we're going to take our 8 feet and we're going to multiply it by 9 feet. Now the big deal here is we get to use a different times table, a different multiplication fact, if you will. So let's go with 8 times 9. That's going to give us 72. Everybody got that one, right? You knew 8 times 9 or 9 times 8, however you want to look at it, is 72. Now we got feet times feet, which is going to give us feet squared, or as we like to call them, in good old American English, whatever terms, we call those square feet. You say I used the word English there because that's called English measurements. We're using feet and inches. Metric, those are meters, centimeters, and all those things. We still love our feet and inches here in the United States of America. All right, we're one of the last places that still uses all those things, but we still love them. And you know what? As long as we got them there, we can still deal with them. Still with them. Square feet, that's how we measure our area. All right, now let's go to another little switch up here. Let's see what we've got with area and perimeter of a square. I went ahead and drew the square because there's a little bit about the square. A lot of people get squares and rectangles mixed up. There is a relationship. Oh my goodness, yes, there's a relationship. By the way, notice I'm putting all these little right angles in there because that's the point. With a square, and also you have all these sides the same. So I don't need to know length and width. I get length, I get width automatically, all right? If you give me the length, I got the width also. So in this case, we're going for inches. We're going to go 9 inches right there, okay? And you know what? We got a 9 inches down here also. Now, what's going on here with this thing? First of all, it says find the area. So let's go for area. The area formula, remember, for a rectangle is length times width. You said, well, Ernie, are squares rectangles? Yes, they are. Squares are rectangles. Now, are all rectangles squares? No. All right? But when we have this little requirement to be a square, you got to have these 4 nice little corners, all right, 4 90-degree angles, right angles. You've also got to have all the sides being the same. Not all rectangles have equal sides. So again, squares, yes, they are rectangles, but are all rectangles squares? Phew, boy, it gets confusing, doesn't it? Not necessarily. You've got to have all the same length. All right, we good? So anyway, we're going to deal with all being 9 inches here. Okay, and we got them over here. Might as well put it in there. I know. You say, Ernie, go ahead and finish it. So what's the perimeter? The perimeter is when we add them all up, the area is still length times width. This case, it's basically side squared, which means to find the area, we're going to say 9 times 9. There's another one of your times tables, folks. Yes, it's going to give us 81. It is so important to know those things. And by the way, they are going to be square inches. That's your first thing, all right? The area is in square inches. We had inch times inch, which gave us square inches, all right? Now, here comes the perimeter. Perimeter is going to be equal to, well, we could add 9 plus 9 plus 9 plus 9, but you know what that is? That's repeated addition. Let's just multiply it 4 times 9 and take good care of this. And we're going to have 36 because we know 4 times 9 is going to give us 36. Not square inches this time, because I didn't say inch times inch. 4 is not 4 inches, all right? 4 is just 4. So this is going to leave us with 36 inches without a square effect, all right? And remember, perimeter is just going around the square. Area, all that space in between, all right? How's that? That looks pretty good. Square it and shade all in there. That's your area. That's your area, all right? So perimeter, area, rectangles, squares, money. Let's go back to a rectangle. Let's go back to a rectangle. Here we go. One more quick shot here. You're getting this down pretty well. I don't have to really talk you through this too much. Area formula, how about it? Length times width. Let's just go quickly to the source this time. This time the length is longer. So let's put it in there. We'll put 12 feet. And we're going to multiply it times 9 feet. And again, straightforward. Uh-oh, you know what 12 times 9 is? I hope you do. Hope you do. It's going to give us 108. 108. And it is, as we said, feet squared. Get in the habit of that. Feet times feet gives us square feet. And we end up, let's translate that into square feet. 108 square feet. It's so easy, right? If you know your times tables, it's so easy. And to think of how to get to square feet, if we were going to do volume, you say, volume, what's that, Ernie? That's where we have length, width, whoo, and then we get height. We go to depth, all right? 3 dimensions. We'll be into cubic feet if we had a 3rd dimension given to us, what our height would be. But we're only on rectangles. That's all you got to worry about right now, okay? That's volumes, all that good stuff later on there, all right? So let's take a little twist on our rectangle here. Let's take a little twist on the rectangle. It says find the length of a rectangle if the area is 63. So this time we're starting with our area. Square inches this time. The width is 7 inches. So what we're going to do is figure out what is the length right up there. That's what we're thinking. What is it? What is it? That's our important moment right here. So I'm thinking, I hope you all are too at home. We always think on T and Learn Mathline, don't we? Now, what times 7 is going to give me 63? I gave you something going evenly. It'll work evenly. It's not going to be some crazy fraction or a crazy decimal. It's actually going to be, yes, 7 times something. We could put that as an X. We could put that as a P. We just put it as a blank is what I'm going to do here. What number goes in the blank there? That gives us 63. All right, in this case, it's going to be 9. And by the way, that 9 represents 9 inches. Because how come? Because we've got to get, this is square inches, right? So it's got to be inch times inch to give us the square inches. And there you go. That one wasn't so hard, was it? Pretty straightforward. Works out pretty nice, doesn't it? Now, go back to one more time to our square. No picture this time. No picture this time. Let's see if we can do it without the picture. All right. Our next problem here. Find the area and perimeter of a square with length 12 inches. Remember 12 on all sides. So area, we're going to take, and this time it's inches, so let's do it. 12 inches times another 12 inches. And that's going to give us 12 times 12. You got that? Everybody knows 12 times 12, right? I hope you do. 144, and it's going to be square inches. Inches times inches gives us square inches. Now, in nice English terms here, yep, how about it? Square inches. 144, there you go. That's where we are. That's where we are. That was easy. That's area. Perimeter, remember, all four sides added together. We'll use perimeter. I'm going to take 4 times 12 inches. Now, I didn't say 4 inches times 12 inches, did I, folks? Just shake your head. No, you didn't, Ernie. You didn't. All right, what we're going to do is multiply 4 times 12, gives us 48, and that applies to be our inches. So there we go. Remember, square inches for area. You're just walking inches around for perimeter. 4 sides to the square, that's where the 4 came from. Again, pretty straightforward, isn't it? Multiply the length times the length, which is 12 times 12. Here, we're doing the multiplication also, 4 times 12. But remember, 4 does not represent inches, represents the number of sides, number of lengths that we're using. So you got it going there. Area, perimeter, a lot of fun, a lot of fun. Now, we always like to have at least one challenge problem, even on what we think are, quote, easy shows for you guys out there. I hope this has been easy today. If you know your times tables, it is. If you don't, hopefully you've picked up a little more on them as we've gone along. Let's take a look at one last problem, which is kind of crazy, all right? If the area of a rectangle is 54 square inches, all right, in my mind, I'm thinking a rectangle. I don't know the dimensions here, though, folks. I don't know the dimensions. It says what integer values, that means nice whole numbers. We're obviously going to be positive on this because can't use negative lengths or widths for a rectangle. So what integer values less than 10? So we want them both to be less than 10. So that makes me start thinking, could it make up both the length and the width? All right, 54 is the magic number. Right there, 54. And being less than 10, that just simply tells me they're going to be single-digit numbers. All right, they're going to be single-digit integer values. So I'm already thinking I know what the answer is, but let's look at other options. There's more than, there are a lot of options that could give you 54 that are integers. Let's talk about them. First of all, how about it? 1 times 54. Oh, 1 times any number. So perhaps that's the length or the width. That could be the other length or the width, all right? It gives us 54. It's a very, very long and very skinny. But it's not. Did you see my skinny? It went off the thing. There we go. Very skinny. How about it? Very long, very skinny. Now, what about 2? 2 will divide into 54 evenly. I see we're starting to think about numbers that are divisible. All right? And 54 is divisible by 2. All right? So 2 times 27 will go. But notice 1 and 2 are cool. 54 and 27 are 2-digit numbers. 2-digit integers. Can't work with those. Will 3 go into there? Will 3 go into there? I believe it will. 3 times, what you going to get? I think 18. 3's good. 18, too big. Does not, see what we're looking for? We're looking for 2 values, 2 numbers less than 10 that would make up the length and the width. Didn't say which has to go where. Just going to make up both the length and the width. All right, you know I'm coming down to the next one. 4 doesn't work. 5 sure doesn't go in there evenly because you got to have a 5 or a 0 on the end. 6 is my next choice, and there is my times table. 6 and 9. 6 times 9. So if I take 6 inches and times 9 inches, guess what? I got 54 square inches, which is way we check back through. Could it go 9 by 6? Sure. There's no rule that says length has to be longer than width, okay? That's one of those things that we get in our mind a lot of times. Well, none didn't work right because if you draw it that way, it's okay. You just sometimes have to shift your numbers there, okay? But you think about it, if you don't know either dimension, you've got some flexibility in how the figure is going to look. You have the figure flexibility, all right? Ooh, figure flexibility. Look, got it right. Hey, folks, thanks for tuning in this afternoon. We've looked at areas, we've looked at some money problems, but it's all about multiplication. We want you to know those times tables, those multiplication facts that you have from third, fourth, fifth on up, because you never get away from them. You get them with fractions, decimals, my goodness, with everything. And of course, who can forget long division, which we all love also. Got to multiply before you can do long division. Again, thanks for tuning in today. We'll be back again tomorrow. We'll be back again next week. We'll be back all summer.
I used to hate writing because I have Tourette's syndrome. It's a neurological disorder that causes me to twitch and makes my hands cramp up. It's annoying. I watched Downton Abbey with my whole family, and I love the series. It just created such a cool universe. I didn't know that writing could do that. I was so obsessed that I went and I researched and I learned all that I could about the Edwardian era.